So, got a couple more speakers, and Dave Temkin from Netflix is up. Dave rejoined Netflix a little while ago, and over the past, within about 18 months, sort of built out their whole CDN to handle all their streaming and converted all their traffic over into their own CDN. So it's an amazing achievement. I think Jay at the beginning of the conference today talked about internet bandwidth in North America and around the world, and the folks in this room who are responsible for that from an operator perspective. I think we probably all know that Netflix is by far up in front of that. And I think if you look at some of the reports, 35% of North American bandwidth, and it applies even in regions where you wouldn't expect Netflix to be. Somehow they're taking up a lot of that bandwidth. And so with that, I think Dave's going to kind of walk us through how, from a low layer, how they built that out and managed to service all our TV shows and movies. So, Dave, help us.
Thank you. Okay. Okay, so in the vein of a live demo, I was going to show you guys the first episode of House of Cards Season 3, for those of you watching Twitter. But unfortunately, it got leaked out to everyone, and they had to take it down, and Kevin Spacey was mad. So unfortunately, you just get to hear me talk about data centers. And not nearly as fun, I know. And it's actually funny because I would have loved to get up here and given a similar talk to Fastly, to Artur earlier, because I was watching it and I'm going, oh, us too. Oh, that's really cool. Like, hey, we've built this platform. We hate routers. Load balancers are stupid. Like, make your application smart. And then I was like, wow, I could have included all kinds of great profanity in my presentation if I'd just known that I was going to be after him, because I always have to go back and like censor it. Anyway, so what I want to talk about is, we've heard from all layers of the stack here so far today, right? We've heard about applications like we just did in the last talk. We heard about Fastly talk about kind of soup to nuts, but mostly ignore the layer 0, layer 1 stuff, right? And we heard a bit, at the layer 0 level, layer 1 level, layer 2 level from Facebook. But I really wanted to talk in detail about the challenges that we faced as we deployed hardware around the world. Now, I could talk for like 4 hours on this, and so you guys probably will think that these slides are a little abbreviated, and they are, to try to fit in a 45-minute slot. I'll be around after this to talk. I'm happy to answer questions, though. So, just some quick background. I rejoined Netflix in 2011, as Omar had mentioned. I had quit Netflix because everything was moving to AWS, and frankly, that wasn't really interesting to me, being an infrastructure geek. I got an IM from my former boss while I was sitting at a job that I hated, and he said, we think we've changed our mind, we want to build a CDN. And for those of you who know my boss, you know that, like, if he called you up and said, hey, I need a new fry chef, and I'm the manager of McDonald's, you'd probably follow him. So I went back there in September 2011. We built our own boxes. I added the fact they were red because it was so important that the Facebook box today was blue. We originally, the original plan was to deploy as many of these as possible inside of ISP CDNs, or inside of ISPs, sorry. So they look like, that's one of the pictures of the original boxes. We have Mike in the audience who helped design it. We had these grand ideas about putting these quotes on it. That was the first one. We never really followed through with that. What the hell, Mike? But anyway, we built this as a single purpose system, right? So we have the advantage of the fact that we do one thing, and I think we do it pretty well, which is deliver video to our customers. And they're our customers, so we know where the video is going. It's our content, so we know how to get it there. And so we get this advantage of just being able to build this single homogeneous system, but the challenge is the scale. So we thought about what this project would look like. And when I originally came into Netflix, it was to help work on what the design would look like for these caches that would go into ISP networks. It wasn't to go build a bunch of infrastructure. As a matter of fact, when I was going to come back, Reed, our CEO, said to my boss, Temkin doesn't think he's going to go out and build a bunch of networks, does he? Because they didn't, like, you know, the idea was that we weren't going to have a network. It was just going to be caches. But we realized, no, we actually need to build like a fully functional standalone CDN. We couldn't feed these caches from, say, the Akamai's of the world. There's no money in it for them. It's not really their sweet spot. They don't want to enable other people's deep caching within networks. Great. So, in the vein of a simple system that we could effectively build in building blocks that is designed around a known set of content, a known set of users, we could take these pieces. So these red Netflix blobs, which incidentally are our old logo, so I need to not show our marketing people this. But anyway, these Netflix blobs are effectively caches. So we can take any number of them and shard up content between them, and all this is programmatic, and it doesn't really matter for the purpose of my talk, except for to say that, you know, you take a bunch of them and put them in one location, and you get 100% offload. You take a few less and put them in another location, and you get 90% offload. Take a few less, and maybe you get 60 or 70% offload. But we can build these in building blocks from all the way from the caches that are inside of other people's networks straight through to our peering points. And because we do that, effectively you get a tiered offload, where you know you can get, you know, 60 to 100% offload inside of a network, all the way up to 100% offload if you directly interconnect with our network. So, enough background. Let's talk about what my focus is here, what I want to talk about, which is layer 0. We had to build this quickly. The goal was to be off of third-party CDNs, the Akamai Limelight Level 3, by 2013. And we really did make that goal with a few little caveats that not really worth bringing up here. But the reality is we wanted to be able to do it at a reasonable cost, right? So we have the benefit of vertically integrating this into our business and using the scale that we have from everything else, right? We're not a CDN. We don't have to hire a separate HR department. We don't need a separate marketing department. All of these things that enable the scale of a CDN, we already own within our business, right? So hopefully we should be able to do this cheaper. We should be able to do it with better quality because we control the path between us and the end user. Neutrality issues aside, in general, we do have good control over how our data gets to an end user, especially considering the fact that so many of our software clients, you know, whether it be on an Apple TV or a Mac or a PC or whatever it might be, or PS3, we write that code, or that code is written to a very strict SDK. So we can make that thing do whatever we want. We have devices that we can run reverse trace routes from, which is just awesome functionality. And it needs to be scalable, which is where I come in, right? We need to be able to deploy this rapidly wherever we might need it in the world. So that was the very first rack of the OpenConnect CDN that we built. That was my wiring. I don't do much wiring anymore. I don't know why. But anyway, that was kind of our first attempt, and we actually served like a decent amount of Bay Area traffic from that for a few months until we decided to scale up the project. So if you watch Netflix out here, you might have come off of those servers at some point. Anyway, so this is what it looks like today. And I skipped a little period in the middle where our servers were white because we couldn't build red chassis. But that last rack that I showed you probably had, I don't know, what did you say, Mike, 40 gigs of capacity if we were lucky? Not even. That is 3 terabits in 6 racks. We actually hope to be able to squeeze even more out of that, but that's actually a conservative number for that. And that's 100% offload of Netflix traffic within a region. Just another location, you know, just another picture because I like showing this kind of stuff off. Again, 2.4 terabits of capacity. That POP was deployed in less than a day, just to give you a concept. I think that's Denver. We don't always store our ladders in cabinets, but it was the best picture I could find. And we don't always store our extra patch cables on top of the switches. Anyway, that's you know, a good sample of what we rapidly deploy. And again, you know, you think about when we talk about terabits and terabits of capacity, Netflix serves dozens of terabits at peak every night. I'm not allowed to say the actual number, so we'll stick with dozens. So what you just saw in those last few pictures are two different types of caches that we deploy, right? We have what we call our Rev C or Rev H caches. They have 36 8-terabyte spinning drives in them, as well as some SSDs. Those are not really as important anymore as they used to be. We use those, we call those our offload boxes, and I'll refer to those in other slides as offload. That allows the deep library storage that we need. So if you go back and look, those are the boxes on my right, your left. Those have the drives in them. The boxes on my left are what we call our Rev Fs. Those are up to 40 gig flash appliances. Today we're getting like 36 gig out of them, so I'm just going to call them 40. And those are loaded with SSDs. And the whole point of those is to take the most popular content, House of Cards, whatever it might be, and put it at as far to the edge as we can in a really, really high offload box. That hardware, if we embed our hardware in someone else's network, we use that same exact hardware. We use those Rev Cs, Rev Hs. I don't think we've deployed any Rev Fs inside of other people's networks at this point, but we made it quite clear when we were talking to networks that we were deploying inside of that, hey, it's really important. We recognize it's important that we eat our own dog food, which all the Facebook people will absolutely recognize, right? We wanted to make sure that we weren't building something that was like super efficient to go inside of our data centers, but like really inefficient when we expected someone to put it in their data center. So we're paying for the same amount of power, we're paying for the same amount of space, if not more, than someone who was nice enough to put our boxes in their network. More, because everyone likes these kinds of pictures. On my right is an offload OCA, so that's primarily flash based, and on my left is a storage OCA. We originally, the very, very, very first iteration of these, what we called our Rev As, were based on the Backblaze reference design. We've since moved significantly away from that to our own design. But we do share all of this. The URLs at the end of the presentation, openconnect.netflix.com. We're happy to talk about this. Like I said, one of the guys who was the primary architect of these boxes is here today, is Mike Peterson. You see him in a blue and white striped polo shirt. So those Rev Cs, Rev Hs, I call it 560 watts. Mike and I argue back and forth about what they're actually supposed to be spec'd for. But, we've got literally thousands of them in production, and I know how much they draw at peak and when they're not busy or idle. And so if you just want to distill that down to watts per megabit, you're 0.31. Rev Fs, 250 watts, that's where things start getting really interesting, right? So 0.006 watts per megabit. They from a power perspective, they cost nothing per megabit that you deliver. So we deploy them in these groups, right? You saw in those other pictures, you saw 10 Rev Cs per rack and 30 Rev Fs. What that does is, the Cs are really space limited, right? We deploy the same racks everywhere around the world where we can. 44U, APC, blah, 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 some model. We know we can fit 10 in there. We really can't fit anything more. We can't reliably get more space than what can fit a 44U rack. In some data centers, we've had to compromise for 42U, and luckily the design will still fit inside of that. It's just a little tight. And those Rev Fs, that's power limited. Going to an Equinix or some other colo vendor to try to get more than 7.5 kW per rack is actually a pretty big challenge, and I'll explain why in a few seconds. So, when we decide where to put these things, we have to think about where, when we launch a new market, say, Netflix, we just went, our last major launch was France and Germany. So myself and my data center guys, my network guys go, hey, where is the densest interconnection spot in this city? So let's use Paris as an example. Paris, it's Telehouse 2. Those of you familiar with facilities know that Telehouse 2 is really old. That facility is, dates back a really long time, and the infrastructure shows it. So two things. One is, you can find a tweet that I never should have sent with a picture of the deployment we did there, and the responses to it ranged from, oh my God, they put a terabit of capacity into Paris, they're going to destroy the French internet, and luckily, we have not destroyed the French internet, and we deployed a terabit of capacity because when we look at what the forecast is over a certain number of years and how many boxes it takes to fill a catalog and things like that, it made sense. That's what all the blocks added up to, was around a terabit of capacity. To me, that's a point of pride. To the network operators, that was a point of like sheer terror. So anyway, that was one takeaway. The other thing that people replied was, I thought Telehouse 2 has been out of space and power for like a decade. And magically Netflix can go deploy a bunch of racks and serve a terabit from here. Like, why are we all getting screwed and Netflix like gets taken care of? I will say we didn't really have to fight for that space. The one proud thing that we do have is the fact that people like our brand and they want to go out of our way for us. But the other side of it is we're so efficient on the space and power that we don't really have to, right? We're not going in there and asking for 200 kW, half a megawatt, something like that, right? I go in to deliver a terabit and I ask for 40 kW. And they're like, oh, well, we can like ring out 40 kW. We'll find that somewhere. And they did. So we go there because we know from a network build perspective, it's simple. I can reach almost every single major network that I need to reach in that one building. And so I sacrifice potentially density for going into a building where I know that I've got the most amount of connectivity. If you contrast that against, Facebook, Google, Microsoft, they'll go and lease, football fields of space, megawatts of power from a DuPont or a Digital, or even build their own, and then run fiber from that back to one of these facilities. In our case, it makes no sense to do that because I can deliver this traffic from such a small footprint. I'll spend more on building that metro optical infrastructure than I will on the entire rest of the deployment. That's not to say we don't have places where we've got metro optical. Like New York is a total frickin' mess from a metro optical perspective because you got to be everywhere to reach anyone. But we have other cities where we go into, say, San Jose, right? You go into Equinix and you can reach everyone you need to reach in San Jose. Atlanta, you go into 56 Marietta. People may not make those decisions because those are considered legacy facilities, but for us, they work well. Sometimes, though, we compromise. We go to the second most popular. I think we ended up in the second most popular in Frankfurt, Germany. We're in the most popular in Dusseldorf, still using that example. However, we're actually literally in the attic of the building. You have to walk up a wrought iron spiral staircase to get into our suite. And nothing outside of the suite itself is actually air conditioned. So, as I mentioned, the lower rung, the 5.6 kW or so, is easy to get. We actually ask for 6.5 kW of power per rack. We generally design the entire suite around that number. What we then do is chop it up and go, okay, well, some racks actually need 7.5 kW. Some racks are going to use less. The racks where we put our network equipment, which I'm going to try to stay away from because I'm not giving you a network talk, we provision at 6.5 kW, but really only draw 2 or 3 kW. So we'd like to go beyond that. We actually think we can get significantly more offload out of those RevF equivalents. But when we think about that, that means we've got a 9 kW rack. For those of you versed in power, we actually deliver everything within these colo facilities is in the US, 208 volt, 3-phase, 30 amp. And that gives us anything within that range. And most colo providers understand the fact that, hey, we're not going to use all of that in most of the racks we provision, because I think that's 12 point something kWd rated. All right, so we've got our space and power picked out, right? We know where we're going to deploy it. This makes a lot of sense. Now I need to go get a cabling company in there to run a whole bunch of structured cabling, right? And I'm going to spend a couple $100,000 and going to have this really, really static infrastructure that's impossible to change later on. It was mentioned earlier talking about the desire for fiber to be reusable in multiple deployment methodologies, and having a bunch of structured cabling run doesn't really work for that. In our case, we are still deploying a ton of 10 gig, right? Most of our cross connects with most of our major providers, or interconnects with major providers and major ISPs, are still 10 gig. These guys can't get dense 100 gig into their big router platforms. I'm not using a big router platform. I'm happy to do 100 gig. But they're in the position where they've got Cisco CRSs and Juniper MXs and PTXs and whatever, where they're lucky to get 4 by 100 gig to a slot, but they're able to get 48 by 10 gig in a slot. Or, even worse, I think unlike the ASRs, they're still at a 2 by 10 gig, or 2 by 100 gig in some cases, where they can get a 36 by 10 gig in the same slot. So they would much rather use 10 gig, especially because we're paying for the cross connects. Anyway, we do use a decent amount of 40 gig now to our servers, and out of we're mostly on Arista. Out of our Aristas, we're doing PLR now, where we take a 40 gig LR optic and chop it up into 4 by 10 gig and use that for interconnect. Oh, ouch. That was a picture. I don't know what happened to that. Okay, so I'm going to skip that slide. But what I was going to explain was, you can go and, I don't know, I'll show you some pretty pictures in a moment. This was an example of what I was showing in the other picture, which is one of the custom cables that we had designed for us. And what this allows us to do is, we're big users of MTP cabling, and I'll explain that for a second. But what this does is allows us to know predictably for every single deployment we do, we need this cable type, which is a 4-digit part number at this length. And that's it. That's how we order cabling for a site. And we're done. And then the engineers, the techs who go to install the router, which can be done either by our own staff or by a contractor, get a bunch of bags of cables that they unfurl and run between the racks over ladder cabling. And I don't even need fiber tray. We can just use plain old ladder, because this stuff is armored. So my next slide is going to have a Google image search of cable porn. I made a huge mistake and had to slam my laptop shut, so we'll just go with kittens instead. So as part of this, we had to think about how do we get this data out of the data center, right, out of our location. And so, as I mentioned, in the case of a lot of the ISPs whom we have to interconnect with, they're still happy with N by 10 gig. Not so much for us, but it is what it is. And so one of the things we thought about was, okay, if you look on my right, your left here, you've got a standard Equinix panel, or standard Equinix, what they call DMARC rack. That's where they hand off all your cross connects. So if you look at that, you're lucky to get 192 cross connects in that rack. That's nothing compared to what we actually deploy in a large site. I think this site is actually Chicago, which is our largest site in the world. 192 per rack means that in a data center like that, I would need like 4 of those racks to get the rough equivalent of patch panel space that I would need to get the data from the servers that I have in that cage out. And this is just burning space, right? We were lucky enough that we finally talked Equinix into, in the last literally 12 months, supporting LC cross connects. Like this is some sort of magic voodoo that no one's used LC ever, but they will finally support LC cross connects. But they'll only put 24 in a panel, not 48. So not really any point to it. Anyway, instead, we went with the design on my left, which some of you may have seen different versions of before, but not in the same kind of rapid deployment methodology, which is that Equinix just lands a cross connect on the front of one of those panels. We tell them when we give them an LOA or we give them an order, we tell them exactly which port and panel to land it on, and that's it. They just drop a direct, a cable that's coming in from the ceiling and plug it into the front of that. They're not so great at cable management, as you can see there. However, it's still better than the alternative. So I've already talked about the first 2 things here, the main thing being the only levers are lengths and types, but this allows for this complete solution, right? Everything from that DMARC rack, where that plugs in my cross connects, which I'll show you in a second, go over to a router or a switch. Everything from there, it's all done. It's all shipped to the site in a box that's pre-built, pre-measured. No one has to screw anything. There's no field termination of any cabling. It is plug and play, literally. We can usually have multiple terabit sites online in less than 2 days. A lot of time is spent when someone goes to a site to deploy it doing stupid things like unpacking or like getting access to a building because the owner of the building is different than the colo company and someone forgot to update an access list. People spend hours on that kind of stuff where we're paying a lot of money to have them there, and they're just sitting around doing nothing waiting for someone to go send a new Excel file. But once people actually get in there and get working, 2 days is pretty good. And the final point on that is when you do the design where you have everything pre-terminated and you can build this structure, you can never underestimate the value of never having to have a colo operator touch your equipment. It is beautiful to know that like they're not going to unplug the wrong cross connector. They're not going to power off the wrong box. Do we have to have them go out and like jiggle something from time to time? Sure. But that's like once every few weeks out of my dozens of sites instead of multiple times a day. So as I mentioned, the thing that really drives a lot of the scale is we do a ton of MTP cabling. We have those cables custom made. They're all MTP based. This is a cassette that we had custom made for us in order to break out those demarcation cables so that basically we slide that cassette in to the panel that I showed you before. And then in the back, we plug 3 MTP cables in. That runs in a single cable assembly, but 3 MTP connectors over to a router or switch where it's then broken out. And we're using that for pretty much everything at this point. It's not cheap, it's inexpensive compared to field terminated cables though. Here's an example of a recent deployment, 3 terabits of interconnect. That's the other side of what that panel is. So those of you versed in fiber will know that the blue is multi-mode that's headed over to the servers. I really wish 40 gig would get on, LR would get on price parity with SR like we've seen with 10 gig for years now. But until then, it just made a lot more sense to deploy SR. However, when we go to look at 100 gig, that decision won't be stupid. So anyway, the stuff on the right, the yellow, that goes and maps to those panels you saw. And so to my point earlier, there's never a reason for a data center tech to touch where a cross-connect lands on our equipment. Here's kind of a block diagram of what that looks like. So when we have a deployment guide now where either we, as in I've got a data center tech in our group and our network engineers, or a third-party company that we will send out from time to time to do our implementations for us, literally have a guidebook that tells them, here are the parts you're expecting, here's what plugged into what, and just go do it. And if you run into a problem, call us, send us a picture, and say, what do I do? And so we send this to them, and they generally get it. Now, obviously, this is just a tiny piece of a 20-page guidebook. But in reality, this is all we really need. That Arista that I showed you before, it wasn't just random, the layout there. And the layout is done for a few different reasons. First of all, it's done to give us predictability. So every single Arista in my network, which is dozens of them at this point, that we use as an edge device. Again, I'm not going to talk about why, because that was up to the other talks. But every single device is predictable. We know where everything plugs into it. There's no need to have like a per site map of this stuff. We know maybe it's a small site, so there's less things plugged into it, but they're still all plugged in the same spot. DMARC is the stuff that goes over to the other side. We've got all these other things not really worth going into detail over, but you can see it's a pretty efficient use. The other reasoning for it is the way that the queuing works on Arista line cards. Now, in the last 2 months, they've released code that does dynamic VOQ mapping, but in the past it was static, and so we had to know exactly where everything was plugged in and go in and map that stuff ourselves. So, because it's all the same, we can make these deployment decisions really quickly, right? We know exactly what we need to go and ask a colo vendor for. There's really no negotiating aside from, how much are we going to pay for that space, how much are we going to pay for that power. And in many cases, like use Equinix or Telix or any of the other major guys as an example, we already have that pre-negotiated. So we know what that space and power is going to cost us, and literally it's just a line item order to get it done. It allows us to generate the bill of materials to do an install very quickly, right? we can basically spit out a spreadsheet that says, here's all the things that need to be ordered to get this colo online, get it ordered. And that can be done very, very quickly. And we can go from signed, we sign that order form, to having a site live in less than 30 days. I think our record is like 10 days. Most of the time it's waiting on the colo vendors. It's not us. We can get these things done very, very quickly. So I'm going to cheat and talk a little bit about network, because even though I said I wasn't, and explain why we have this architecture, why I'm not talking about these big giant routers, right? So first of all, unlike many of the people in here who are talking about data center networking, I have no opportunity for aggregation. Those Rev Cs, those 2U boxes that have 2 by 10 gig plugged into them, they push out 18 gig of traffic, right? And we may even be able to get more out of them. The 1Us that push 36 gig on a 40 gig NIC, we actually think we'll be able to push to 40. And we actually think we can push them beyond 40, but I don't want to burn the second port on the switch until like maybe it's, 60 gig, right? So why would I aggregate that if I can get line rate out of it? So I'm not going to do any top of rack. It's just yet another thing to fail. It's another thing to manage. Just keep my network simple, right? So for us, big chassis is best. And so maybe a 6-pack could be interesting for us, but it's not red. And I don't know if it's like factory customizable. Can I order it in red? Is that like a $500 option? Pearlescent red. So we're going to stick, we think, with off-the-shelf platforms, probably for the next at least 18 months. We're very happy with the support that we get. We don't have the scale because we don't aggregate, right? We're not building a large spline. We're not putting a switch in every rack. We don't have the scale to white box our own stuff. We can certainly join in with other people on other projects that are going on. But the reality is that my entire network team for these dozens of terabits is less than 20 people. And that includes provisioners and business ops people and stuff like that. So why am I going to get myself into a world where I need to go and spec hardware? However, we have had our own effectively routing platform forever. Since the dawn of Netflix streaming, we've had our own traffic management, right? We know where a user's coming from. I like to say that what our team does, the Open Connect team as a whole, is responsible for everything that happens after you press play. And there's all kinds of stuff that goes on when you hit play that we take into account when we assign you where we're going to serve you from, who we're going to serve you from, what we're going to serve you. And so we can do all that. We just got to figure out how to feed that into network heuristics. We're already well underway with doing that. But it means that we don't have to buy big, expensive routers anymore, right? I was buying a ton of Cisco ASRs for a while. I was buying Juniper MXs, and I feel the same way about Juniper as Arthur feels about F5. So I don't have to buy those anymore, so I don't really care. This is my most complex network, right? And this may look, actually, I can't even imagine this looks complex to anyone in this room. I don't know who I'm kidding. But anyway, really, we have locations that do still have big, expensive routers on top of, and in that connects, a large table peer, someone who sends us tens or hundreds of thousands of routes. Our transit IXPs, because those are unpredictable. You could get 500 routes or, 20,000 or 50,000 routes off of an IXP, depending on the location, or like DKIX, we can get 250,000 routes. Anyway, those go into those routers. We have, offloaded and catalog connected there. We also will effectively do what we call router on a stick, where we're sticking an Arista underneath that, connect more offload, connect a small table peer, take someone where you've got a finite user set behind them, a Comcast or Verizon, something like that. They'll connect directly into there, because that Arista can actually take that table. For those of you in the room who use Arista, you should probably be aware of a feature that they implemented for us, which I think will go into GA, where are we in February? Early March, which is to map 24/24s through /20s into the LPM table instead of into the fib. And so because you're doing that, you get another 50,000 prefixes worth of life out of the box, which that can be life or death in a peering pop. Certainly not a long-term solution, but it's a nice medium-term solution. And then, like I said, we do have certain metros where we have DWDM, where we'll then extend that model, and we actually just do colored optics inside of the aristas to a passive mux. We don't build any kind of complex optical systems. There is no reason to. We're not doing any long haul. Anything that's long haul, we buy lit. So if we have a metro, we do it all quite simple, and we just build the resiliency into the application. This, again, a slightly simpler version of it. I'm going to actually skip that slide. This is what we're going to, and this is what I have. So I just showed you that Denver pop, for example. That's what that is, right? It's two of those next to each other, but that's all it is. And so what I need to do is take that and replicate that and get that so that the data out of those platforms is integrated with all that great application data we have. And so that's what my team is working on for the coming year. So on that note, if you want to help with that, here's how you can. So our website, our job site, my email. I'm happy to take any questions.
Oh, we got the mics right behind you. We got the. Or I can come over here.
So I was just going to say, this is the big chassis Arista box, which has the Clo network inside of it.
Yep.
So is that because you do have a fairly high amount of east-west traffic balanced, or is there, what's the ratio of that?
There's almost no east-west traffic. So the only east-west traffic we have, there's no. So I could go in a whole bunch of background, but basically there's no such thing as a cache miss, right? Because we know what the user is, we know what they want to watch, and we know where they're coming from. We can map them to a box we know has the content. And so they always go to the box that they're coming from, so that's north-south. Okay. We do sometimes move content, right? If we reshard a cluster or we're filling new content into a cluster, that's like going to be less than 1/10 of 1%.
Okay, so the reason for the high radix box is to map many different transits to the different servers.
Exactly.
So it's doing that. Okay, thanks.
So you also mentioned putting these boxes inside an ISP's location, like a central office or something like that. Is that what you're thinking? So now you do have cache size considerations. Are you going to hit that cache? Is it really going to be House of Cards or, Toy Story or something?
Right. So the one thing about our application is, right, and in general our service, popularity doesn't really change drastically within a day. It may change day to day. Someone might die. Someone might win an award or something like that, or we might release a new series. And so what will happen with that is, if you go way back to the early slides, that'll just flow upstream to something else. However, nightly we'll move around based on popularity, what happened the last day, and we'll move the content around to make sure that that cache within an ISP has that most popular content. Using House of Cards as an example, we will go and push that proactively down to the furthest embedded caches that we can to make sure that people aren't screwed on launch day.
Yeah.
You had two. You had one there and one back there.
Can you comment on how things like packet pacing are going to improve your environment?
We actually have implemented packet pacing in a limited fashion, and we do, it was actually done at the request of third-party networks. So in our case, we weren't actively looking at it, but it was requested that we do it, and so we did it. It seems to have a marginal increase on user quality of experience, and everything we do, it's literally looking at, to figure out whether or not this was good or bad. It's looking at user quality of experience, their bit rate, how many rebuffers they had, things like that. Very marginal difference.
Hi. You talked a lot about video. Are you using your CDN for images at all, or CSS, or any other web-based resources? Is any of this SSL? And if you're not using it for images, what are you using and why?
I wonder if this is a loaded question. Sorry? I'm kidding. So our dirty little secret is that we do still deliver our box shot images and our CSS through Akamai. That's because the system that I just showed off to you is not designed whatsoever to deliver small objects. It's not to say that we haven't thought about it, and it's one of those projects that we keep bringing up and then getting distracted with something way more important, because delivering box shots really isn't all that expensive. We get distracted with something else more important, and we don't get to it. but it's certainly on the roadmap to move to a position where we do deliver all of those assets ourselves. But the reality is that the video is 6 nines worth of our content, worth of our traffic load. So we deliver that from our boxes today.
How would you choose what data center or what of your locations to serve a movie from? Is it based on cost, based on latency, or based on availability of the movies, or what are the parameters you take into account?
So when we make a steering decision for serving content, what do we take into account? So we take network proximity. So if I go all the way up the tree, we look at, is that content available, yes or no, in that region? Then go down the stack and look at, okay, where is that user located? And this is a very simple version of it. Where is that user located? Okay, their proximity is within the U.S. Okay, let me look at their IP address and go, all right, is that, which I looked at to figure out they were in the U.S., but let me look at their IP address. Okay, let me look at my routing table that is sent in by those appliances, which gets it from either the Aristas or an ISP or something, or a router or something like that. Let me look at my routing table and go, okay, what's my best route? And we use basically the standard BGP decision tree with a few little tweaks in it to do that. If I end up with a bunch of equals, i.e. I've got 2 hops to Comcast here and 2 hops to Comcast here, then I fall down and I gotta look at, and all the other things are equal, med and stuff like that. Then I fall down and look at geo, right? And that's just using standard like Akamai Edgescape data to try to localize that to a POP. Obviously, we already know where the content was. We need to make sure that they get to a server that has the content on it. That's done through that same steering mechanism within that POP.
So what if the network latency changes after the user hit the play button? How are you going to maintain that?
So you said the network what, sorry?
That's the internet, like just
okay,
running.
yeah. So assuming that there was no change in experience, nothing's going to change. If a route changes mid-play because, say, a path went down or a path got optimized, but nothing, we're still able to get data to that user in a reasonable amount of time, and they haven't had to step down on bitrate, nothing's going to happen mid-play. If for some reason that experience becomes degraded, right, they're unable to keep the buffer full, the client, depending on the client type, will try another server, and it has, as part of that decision matrix, it has alternatives that it can pick. It'll try another server and see if it can get a better experience. And then if it still can't, it'll just start ratcheting down on bit rate until it gets to a stable point. One other point I wanted to make in relation to the other question before was that we don't care about latency, right? Because once you get a window open, you can just shove data down a pipe. And in reality, when a user presses play, there's a multi-second delay there anyway, and we've already opened that pipe and we're already starting to stuff it full of data. So they're not going to really notice the difference.
All right. Well, thank you very much.
Thank you.